Pune here, so obviously we're covering up all north, north, south, or west part, let's say. Yeah, I think we're good to go, I guess.
Yeah.
Okay,
Yeah,
we're live. Great. Very good morning to all of you here, my dear esteemed panelists and all the audiences joining from different platforms. Very good morning and welcome to panelists. As we are going to dwell into a very promising, insightful, and very interesting session in today's time frame. Anywhere you go, any field, right from the where I'm coming from, automotive, the kind of electronics, the boom is happening. Like you can say, the software driving that electronics or hardware to consumer to any health industry, any industry you talk about, the semiconductor is at the core of this particular industry 4 or industry X kind of a revolution overall. And today we have a really great gathering of this uh, great expert from each of their areas who will give their insights on the topic of navigating the opportunities and the challenges in the semiconductor manufacturing in India overall. So, to set the kind of a context overall, before I jump onto the topic and then get into the navigating that flow of the thought process, getting those insights from each one of the speaker, I would request each one of the speakers give their some kind of a professional journey, background, their domain understanding, and then obviously what they do, what kind of a companies they are doing, representing here. That will be great to so that the audience get a perspective about yourself when you are giving that response. They get the thought process more clearer, I would say. So I will start with Ashok. If you could give quick introduction. Ashok, you're on mute.
Yeah. So thanks, Yogesh, and good morning, everyone. I have been in semiconductor industry from 25 years now. Started my career journey in 1999 from a company called ST Microelectronics in Noida. And then since then, I've been to, privy to both corporate life, entrepreneurial life, and back in corporate. So about first 14 years of my career journey was a semiconductor design fabless side. Worked for companies like Intel, Qualcomm, ARM. Before I left my job, started my own company, design consulting company, which I ran it for 5 years, sold it to a French company. Then later on, I joined Reliance. It was the peak of semiconductor interest hype cycle, and Reliance wanted to foray into semiconductor manufacturing. So I sort of built a business case for Reliance and got very close insights into how that manufacturing side of the business works. Right now, I run my own company, consulting company called Incuba Labs, and I consult multiple companies both in design as well as on the manufacturing side to set up their forays into semiconductor. I also part-time consult in expert panel of PwC and help them with their clients who wants to get into semiconductor. So that's my brief background.
That's great. Since as you said, right from the hands-on design till the thought process of building the business model around. That's great. Great to have you, Ashok.
Thank you.
Next, Santosh.
Yeah, good morning, Yogesh ji. So I am basically an electrical engineer. So I started my career in IT department of Kerala. So last 11 years of working there, and I have handled that some of the clean room project there. Then I quit that government job and started on company that is Semicon Fab Technology. That is in 2000 started in 2023. And it is co-founded along with Dinesh Deva. He has the prominent clean room design engineer. So we have that expertise around 20 years in clean room design and build. So the Semicon is the end-to-end solution for the semiconductor industries. So we will provide a complete EPCM solution for engineering, construction, that testing and commissioning, and we will provide the validations. So that we will provide a end-to-end solution to the industries. And we already done many MOU with the leading nations from Japan, Malaysia, and Singapore. So our main aims to the better technology coming to India, provide better solutions to semiconductor industry. That's all. Thank you.
That's great to hear. Obviously, that's one of the key topic for us to see that how we enable that us manufacturing it to the global standard, and obviously with a make in India or local thought process build up. So great to have you, Santosh. Next, Hanish.
Yeah, Yogesh ji, thank you for having me. I am privileged to be part of such a esteemed panel. So I started with Marposs in 2004 as a service engineer. So coming out from college, then 2008-9 I was moved to sales. In 2011 I got an opportunity outside the company. So 2011 to 14 I was out of Marposs, mainly working with the semiconductor, defense, optics, and other industries. So that was in 2011 when I was first introduced to a semiconductor manufacturing process. And as a salesman, I sold my first equipment into the industry. So that was back in 2011. So 2014, I was again back in Marposs as a regional head for North. So I served this position for around 8-9 years. And around 2020-21, after COVID, I was given the responsibility to develop the new strategic markets. So basically focused on electric vehicles, batteries, HVAC market, biomedical, semiconductor 3C. So that was very clear verticals where we need to focus actually. So now there's a team in place. And very recently, I've been moved to as a key account manager's head at Marposs, with additional responsibility as an industry manager for semiconductor and 3C. So it's mainly on the manufacturing, metrology, and the quality side.
Great.
That's
And
it.
so obviously I know Marposs, but it'll be good to know what Marposs is into. Just a quick.
Right. So Marposs is an Italian MNC that was started in 1952. So we are mainly into measurement, inspection, and testing. So our solutions are from dimensional testing to leak testing to different technologies. So we ensure quality of the part produced with zero defect. And we are normally offering solutions in almost every sector which is into manufacturing. So it is said that almost every passenger vehicle has at least one component that is tested on Marposs solution.
Wow, that's a great data point to say.
Thank you.
Great. So thanks, Hanish. It's great to have you. And as you said, we would like to hear more about your experiences. And as an industry manager for semiconductor industry, definitely would like to have more insights from how your processes or your quality control is enabling to build a global standard in India as well, global standard products in India. Next, Shweta.
Yeah, thank you, Yogesh, and a very good morning to everyone. I'm Professor Shweta Srivastava. I am Dean Academics and Research at Jaypee Institute of Information Technology in Noida. So I actually started my journey as such because I completed my PhD in the year 2002, and then I joined BIT Mishra. So I was in BIT Mishra Ranchi for around 12 years, and in 2014, we shifted to Noida, and then I joined JIIT in 2014. And since then, I have been here, so became professor, then head of the department, and recently I've become Dean Academics, as well as I'm heading the Department of Electronics and Communication Engineering here. So about the institution, Jaypee Institute of Information Technology, it was initiated in the year 2001. So it's almost 23 years to the institute. And we have been like continuously working towards workforce generation, quality workforce generation, and in all the domains, and especially in the area of electronics and communication engineering, along with other IT branches like computer science, information technology, biotechnology. So we are more like, you can say, a model of triple IT, where we focus on IT related branches in the institute. And in the era when uh, uh, initially many of the institutes didn't focus on electronics, we actually focused on electronics. So we have developed around 40 laboratories focused on electronics engineering and in training the electronics engineers here. We have more than, you can say, around 500 students every year who are graduating in either electronics or VLSI or communication technologies. And then recently we have also introduced the electronics and computer engineering, which I think is the need of the hour, because right now, as far as I understand, coding is like English. So everyone should know coding whenever, wherever, or whatever domain you want to work on. So that again is initiated here. And along with that, we have recently developed a fabrication lab here. So here we are giving the training in the fabrication process also to our students, undergrad students, as well as postgrad students. We have BTech VLSI, as I told you, and then we have MTech VLSI courses, PhD also. We have around 40 to 50 research scholars and more than 20 faculty specifically working in VLSI and semiconductors. So we are trying our, you can say, from our side to generate quality workforce, which actually the industry would be happy to take and would be good for them. So that's it from my side. Thank you.
That's great to hear, Shwetaji, in terms of your the efforts and the kind of a proper, not just the courses, the labs, that really gives a hands-on great experiences. And obviously, this is the need of our to make that scale in the Indian environment. So yeah, I think I'm really happy that Dinesh has really pulled up the great panel covering up all the aspects, right? With Ashok covering up the right from the opportunities available in the Indian market, from the business model perspective, his experience coming from that design till the manufacturing and the business model shape up for the Indian, the bigger companies. Obviously, that is a great experience to Santosh covering up once we have the business model in place, how do you enable that locally with the infrastructure available? And then once it's started, you need to ensure that the products are at a good quality and the processes are ensuring that standards. And then obviously for all these, we need a talent overall, and then Shweta will cover up those aspects. So it's great. Thanks to Dinesh and Meshmix for setting up this really in a good panel pulling together. Before I quickly jump onto, let me just quickly introduce myself. I'm the odd man out probably here with a mechanical engineering background. And but obviously I've been into the core powertrain in the automotive, but more as everyone from software industry got into the hardware part as well. And I've been in my past engagements dealt with most of the edge AI neural network chip for automotive applications. So I've been leading their business for India and other regions. With that kind of a background, I really got fascinated with the semiconductor, with IESA, some of the thought process, and then that's where I'm still continuing my interest there. But currently, I'm with Valtech Mobility, leading their India and APAC kind of a business for connected mobility solution. I'm still automotive guy, more from powertrain to the connected or personalized world, essentially. but still a lot of hardware electronics is still come, and the semiconductor chips are enabling that connected vehicle much more, and that's where I'm still engaged on a semiconductor thought process. So with this now, I think obviously we understood the whole background of the thought process, the insight which we have. So let me start with Ashok, as I said, as his experience coming from. I would probably like to understand from him what kind of a unique opportunities do you see in India available, right? And what kind of a factors are creating some kind of advantage to position India in a most prominent player in this global ecosystem. So if you could give some kind of a thought process around, right? As you said, you set up the for one of the largest company, you kind of set up the business model. What were the key factors or opportunities which makes India stand out, suppose, and it particularly at this junction?
Sure, Yogesh. So, see, India is an undeniable end market of electronics, right? And when we talk of electronics, a great deal of electronics is nothing but semiconductors, right? And, I mean, talking in numbers, last year, India consumed about $40 billion worth of electronics, and that's a lot. Now, when we say that we have consumed these electronics, we have consumed these electronics in form of end products, right? I mean, we bought a mobile, or we bought a PC, or we bought mouses or servers and whatnot, right? Now, given that huge local consumption, it is a hidden business opportunity, right? Almost all of these semiconductor, and let me remove this qualifier of almost. 100% of this semiconductor comes from outside India, right? We do not do any of our own chips. I mean, barring some of the chips which are being custom designed, some lab in ISRO or some lab in DRDO. Everything is 100% imported, right? Now, so there are local opportunities because sometimes for a very unique Indian needs, there are opportunities which we can leverage by designing a chip which is localized for the need of local OEMs, right? Then of course there's also a huge strategic concern that I mean, the most important strategic systems of this country are reliant 100% on imported chips, right? I mean, be it telecom, be it our defense systems, aerospace, space technologies, everywhere, right? So I think from the government perspective, during the time of COVID, government realized that this is like stalling the show, right? And then government started to push, right? Now, of course, their motivation is more from the strategic perspective, but then business comes along, right? However, in spite of this opportunity, there is a lot of heavy lifting to be done if someone really wants to make a market out of it, make a business out of it. And those business cases are not obvious, right? For example, if a foundry, Tatas are putting a foundry, and there are other 4 players that are putting a packaging industry in India, the business model of these manufacturing units are to sell their produce to a fabless company. And India, there are no fabless companies of muscle who can buy the produce. Okay, so there are a lot of gaps. So how do you fill this up? Then government realized it and realized the heavy lifting needed behind it, and then they came up with the Semicon policy. So India Semicon policies stipulates that anybody putting 100 rupees in the investments, central government will give 50 rupees, and it is just a grant. It is just given without any anything in return expectation from government. Then states chipped in. They said, okay, every 50 rupees given by government of India will pay 20 to 25 rupees depending on states, right? So India is one of those countries which are giving almost 70 to 75% subsidy on the capital investments. Compare this to the CHIP Acts of United States of America or European CHIP Act. These subsidies hover somewhere around 30 to 35%. So in that sense, this is a very compelling scheme, but people are not exactly queuing up. They're still making their investments in US, in Europe, and the reason for that is the greenfield nature of India. That is number one. Number two, zero market. I mean, we do not have, as I just explained, that we do not have people who buy the produce from manufacturing units, right? So these are the challenges, and hence this can be only solved by the people with very, very deep pockets, in spite of 75% grant coming from country. So that is one aspect, which is manufacturing aspect. But one thing which is sort of I would say has not seen as much push as should have been there is around the semiconductor design side. I mean, semiconductor design is the maximum value creator. So if you look at the total market size of fabless companies or the total revenue add up of all the fabless companies, it is approximately $150 billion. Whereas if you look at the revenue of all the manufacturing units in the world, it is only $100 billion. So it is undeniable that the design produces a lot more value than the manufacturing. Design companies are very, very profitable. Manufacturing companies, apart from TSMC, everybody struggles to make profits, right? A manufacturing unit, a state-of-the-art manufacturing unit would require investments of about $20 billion, whereas a state-of-the-art chip would probably require only $400 to $500 million. So you have a lot less investments required in the design space to create a lot more value, right? Now, Government of India, of course, has come up with a scheme called DLI, which has earmarked about 1,000 crore to push the fabless design in India. But just to give a comparison, the manufacturing similar manufacturing scheme is 76,000 crores, right? So I just wish that there would have been more push on the fabless design side. But whatever is there is a very, very good start. And I hope this will get in the right direction, because what I hear from my friends in METI that probably the next version DLI V2.0 will have a lot more financial muscle and a lot more lucrative. So that's sort of the landscape which I tried to paint.
I think it's really great to hear, and I think you really covered up with good data points, with numbers, covering up where the opportunity or where the value lies more, and then even including the investment required there, right? So it looks like you're more proponent of the design value, obviously being coming from, and I can get that. And equally for me, when I think about my core powertrain, I always see the value, or is in the design side more than the pure manufacturing, because that intellectual property brings more dollar on the table than the manufacturing overall. In today's world, it's more obvious than the previous side. So thanks, Ashok. Moving, probably, I would probably like to once, although as you said, there's 76,000 crores are there available in the manufacturing, and obviously India being with that kind of a labor intensive, I'm
I
not
just
sure.
want to correct it that 76,000 crore is almost gone. So government has approved lot many, and most of it is committed. So
Oh,
just
is
for
it okay? Yeah, but okay, but then that means there is a opportunities already created, let's say, right? So I'm just coming to the same point, that the opportunity of that manufacturing is now it is given that then the whoever has got it, they need to produce now, who start manufacturing, right? And then that's where I'm coming to the Santosh to look at, once this manufacturing gets started, what kind of a challenges which you see from the infrastructural perspective, and maybe one other angle is for the Indian context, and then if you could also share how it happens in other parts of the world, and how you see it should happen in India, how it could be different, and how maybe even your company is also trying to align there. Maybe you can give some example. That will be great.
Yeah, thank you, Yogesh ji. So that before I moving to that, I better to explain that India semiconductor incentives policy. So that is almost gone. We discussed that. So that 10 billion incentive schemes declared on 2021, and that is already started along with that semiconductor mission started. And in that policy, that 50% of total infrastructure cost, total cost reimbursed by the government, and the semiconductor, especially in the fab, that the panel, flat panels, yeah, and that DLS, DLA for the startups, so that the fund utilized for this. So, and that after that, so that declaring these things, that first the Micron, they reached India to start their ATMT plan, and then moves to the Tata declare their actual semiconductor fabrication unit in Dholera, and along with Assam also they started a ATMT plant. So almost this announcement, the India got around 1.5 trillion investments. That is a great news for India, and a great this is treated as the golden period for semiconductor industries. And after that, so the lot of announcement we heard that Adani and Tower Semiconductor announcement another plant in Maharashtra, and RRP Power Electronics also announced their interest. And this will create the ecosystem in India in the first shot. So that the 10 billion incentive scheme already completed, and the government is trying to set up the another levels of scheme, the Semicon 2. So that these the first levels of incentives mainly utilized for that fabrications of actual semiconductor plant, ATMT plant. So I like to discuss about that the strategy in long-term strategy and short-term strategy for India. The short-term strategy, as you know, that the fabrication, the semiconductor fabrication is a complex process in the world. It is required more than 100 services come together and form a big complex system. So that, as you know, that semiconductor fab require is the basic layout. You can see that 4 levels. The ground, first sub fab, it's required for the utility, and the third floor is completely used for the tool hookup, and the terrace floor, the top floor is not terrace floor, the top floor utilized for that AHU recirculations. So this is a complex process for engineering point of view. So that for building up of the semiconductor fab is required around 3 to 4 years. So that the long time process, it is viable, but the short time process, India need a quick momentum for the semiconductor. That I think the ATMT plan is better. So we can easily implement the semiconductor plant. It's required around a small scale of fabrication units. It's around 1 lakh, not much complex process. So we can easily install that the basic process like the cutting and that molding process. We can easily make up the system. So this system will enable the ecosystem. So once started with the ATMT plant, so that will enable that ecosystem. So then we'll move to that second the short-term strategy. We need to skill up for these fabrications required more skilled manpower. India is so as you know that engineering graduates levels is very high, and the labor cost is also very low. So we can utilize this advantage, and we can start that ecosystem. So we can build the this ecosystem. Then we'll move to the long-term strategy. In that long-term strategy, we required right now. We started with the short-term strategy. We will move to the long-term strategy. We required that a complete ecosystem that includes. So as you know that in the semiconductor fabrication units, that right now India's India able to provide that the semiconductor fab is capable for 10%. So we are 100% depending upon the country like Japan, Singapore, US for the fabrications. So we required the domestic companies grown up, and they have to provide that complete solution. For example, in case of gases, the semiconductor fabrication units required around more than 60 numbers of gases. So right now, then Indian companies, like some companies have license, but the complete toxic and pyrophoric gas is there. We need to import from outside country. So that is the difficulties we are facing. So we 100% depending upon the other countries. So we have to develop our own system, our own factory for developing and producing that the gases. That is one thing. Second thing is the wafer. As you know that the complete silicon wafer required, we need to import import these things to India. So that is the things happening. The rare materials. So that's also we need to import from outside country. And the equipment part, 100% equipment, we need to, some equipment is producing in India, but in the 100% major equipments, we need to import from India. So I think its latest announcement is coming up. So government of India focusing on these supply chains. So this supply chain is required for growing and developing for Indian semiconductor ecosystem. That is a better and a better option for India. That's about that infrastructure point of view. Thank you, Yogesh.
Great. I think Santosh, you covered it very well, covering up the updates on the current updates on the who is doing what and what kind of a infrastructure or the supply chain challenges which we're seeing, and we need to make it more, make in India localized to have it. I mean, maybe one of the maybe Ashok, and this is just off the hook question coming up. Is there a way, because see, in the automotive, I'm just trying to apply the same thought. In the automotive, for EV, okay, now if you want a subsidy, the government under the FAME kind of a scheme, FAME 1, 2, and now 3, they've ensured that your content, let's say up to tier 3 level, the 40% or the number goes here and there, but there is a substantial content should have the local manufacturing there, even in the supply chain. Then only you are allowed to get that kind of subsidy. Is there something similar thought process can be applied? I'm just kind of wondering here. Maybe quick question on that.
Yeah, so I think the market access is a very tricky thing here because, as I said, local produce of semiconductors are nil, right?
Okay.
And, if government comes up with any such policy that you need to have so much of indigenization done in a product, right? I mean, for example, if I take this mouse and I say you can only sell it if 40% of its Indian content, right? It'll be tricky.
Okay.
So what government is trying to do, I mean, there's no policy per se, but I just see a trend. So, I don't know, I'm sure all of you must have heard about NAVIC, which is an Indian GPS, right? Now, government has funded multiple organizations to do NAVIC and private enterprises as well as academia. And now, after the NAVIC chip is done, I mean, ISRO is still doing qualification and stuff is going on, but government is nudging players to start using it, right? So it is not a policy on the paper, but right. And in general, I think one observation, and I'm sure whosoever has worked around this so-called preferential market access, a lot of time it is only on papers. The implementation is very poor. So that is another challenge which probably need to be addressed. But yeah, that's the state of affairs.
Okay, that's good to hear out. So I think moving then from that manufacturing infrastructure related challenges, I think I would like to hear from Hanish how the precision processes or the quality control aspects are very critical to kind of ensure that we become a global standard manufacturing player in terms of those products also. So what is your view currently? What is happening there? What are the key challenges, and probably also how Marposs or you yourself are dwelling or helping the companies in those regards? If you could give some more insights on that, that'll be great.
Yeah.
So before that, I would like to add what Mr. Ashok started and put a right context regarding the semiconductor need. And, we are speaking about this opportunity in India. So, we work with IESA. We are part of India Electronics and Semiconductor Association. We are also part of ICEA, that is India Cellular and Electronics Association. So what we understand focused on the focus on the smartphone manufacturing with the China plus one strategy. The value addition in a smartphone in India was around 2% in 2014. And there were few Chinese make smartphone manufacturers that was based in north of India. Eventually, there was a big focus, and the government set a target of electronics manufacturing to 300 billion USD by 2026. Now it has been increased to 500 billion by 2030. The value additions till today is 15%. So it has been identified to increase the value addition in the smartphone manufacturing. India is doing around 27 million smartphones in a year. Sorry, 270 million smartphones in a year. And 30 to 35% of the component is semiconductor. There are around 50 plus microchips going into smartphones. So there was again a need to have a smartphone, to have a semiconductor manufacturing in India. And coming to the PLI, so what Santosh and Ashok said, that it has been consumed, that is right. And now we understand there is the ISM 2.0, now headed by Mr. Manocha of Global Semiconductors. And there will be another PLI, could be of similar extent. Coming to Marposs. So Marposs is offering its solutions in the process control and quality control of the semiconductor from over 4 decades to the industry. So Marposs India is present from last 40 years in India, but mainly focused on automotive. But with our solutions, we can offer and can be a key player in building the ecosystem of semiconductor manufacturing in India. What we do, I'll just read through our solution. So Marposs is offering sensors. So Marposs sensors can be integrated inside an automatic machine to keep under control some parameter that are essential to keep the production quality under control and reach a constant productivity. So we are ensuring the component produced is quality, and we are ensuring productivity and efficiency of the machine tool producing the component. Ensuring, so the focus is process control, the focus is productivity, efficiency, quality, and therefore sustainability. Yeah. So if there is no defect, if the part produced is produced, right in the first time, if the number of parts produced per hour or per shift is more, of course, we add to the sustainability. Our solutions go to almost every machining process or machine tool, starting from ingot slicing to back grinding, to packaging, to dicing, and also focus on the metrology and inspection. So it's a semiconductor is a complex manufacturing process. We all agree to that. So there is a inspection and metrology check required, probably after not if every process, after some process. So immediately we can do the measurement there itself, give the feedback to the machine, or tell if it is right or not, and help control the process. So these are our solutions that we can offer and can be a important player in building the ecosystem of semiconductor manufacturing in India.
Yeah, thank you, Hanish. I think you covered it very well, encapsulating the current and the coming up, the new PLI, which was really good to know overall. I hope it comes in a bigger size as well. Moving, probably I'd like to get Professor Shweta update in terms of, because now your kind of organization is really putting a lot of effort in that talent, skill development, and particularly in the semiconductor industry. Then what are the key gaps which you see, or the major gaps which you see for the talent which is required to meet the industry demand, right? For the semiconductor manufacturing industry demand. I mean, do you get particular key certain inputs? What is the key gap which you also observe yourself, but as also from the industry which you see, and then now uh, you being at that core position, how you are kind of addressing those kind of a gap? Can you give some more light on these aspects?
Thank you, Yogesh. So I'll firstly like to give you what is the present scenario in the country and how the workforce development thing is going on. So there are basically three stakeholders. One is the government and government agencies. Second is the industry, and third is the academia. And what efforts each one of them are taking, because everyone is taking efforts. I'll not say they're not doing. Uh, just the thing is, we need to align them towards the common thing. So what government is doing through MIT, they have this chip to startup scheme where they have allowed all the institutions, like they have given open access to a few tools like Synopsys, Cadence, Siemens. So all the institutions can have those tools. There are some requirement, of course, they need to fulfill a few basic needs of the available infrastructure at the institute. But if they are having that, the government is giving those tools access to the institutions, and then that kind of training can be given to the students for workforce development. So that is a very good scheme by MIT and Government of India. Along with that, AICT and UGC, like these are government bodies who are basically taking care of the academic part. So AICT has initiated a BTech program in VLSI and semiconductors recently, and then diploma as well as postgraduate program. So I'll just give an example, right? 2023, we just went to AICT for a meeting, and randomly we gave this idea to them that can we have some specialized BTech program, because this area, semiconductors, VLSI, you need students or people to be a lot of training is required. It's not that 1 year or 6 months of training will fulfill the need of the industry. So then there we need a specialized program, because MTechs, we are not getting that many numbers of MTech students where the industry demand could be fulfilled. So from there only they took up that idea, and then across the country around 80 or 90 institutions have initiated this BTech program, and now a good number of students are doing a specialized BTech program in VLSI design, which is a very good initiative by AICT. Then from the industry, so and UGC has given a lot of flexibility. So now if you see, there is this new education policy where there's a lot of flexibility, where as what we are doing is the students, we can ask them to finish their majority of credits in first 3 years, and they have 1 year free for doing internships and trainings in the company directly. So that is again another, you can say, flexibility given by the organization. Industry, they have, because initially the problem that we were facing is to reach out to the industry and getting them revert to that. So now industry is also taking that initiative, coming forward and helping. There are several initiatives by them also. And academia, again, we as academia, we and many other institutions, they have started these programs, and they have started training the students in the required domain. The one thing where I feel there are efforts which are needed to be taken up is, one, at the initial level in class 11th or 12th, the awareness is still missing. So right now also, when the student takes up their choices for going for their BTech programs or any undergrad program, they generally try to do something which is easier, or maybe which they have heard about. They have not heard much about semiconductor VLSI for long. Now there is slight change from last 2 years. Again, there is a change, but still there is a lot more awareness that is needed to be going to that level. So that is one thing where a small gap, I understand, is still there. Then there is a gap between what academia feels that we are teaching and what industry thinks that they want. Because whenever a student goes to an industry, they generally say they are not industry ready. So that industry readiness has to come. And for that, I think both have to work together. So right now, what I feel is maybe industry can come forward, and based on their specific requirement, if they can ask the academia that we need, say, 10 students who are trained in this specific maybe specific tools and specific things, and we'll be absorbing them, then I think academia will be happily doing that. But for that, both have to come to a common platform, discuss it, and do it that way. And then the gap can be actually overcome. So for this, again, we have at our institution, because we are placed in Noida, of course, we have many industries nearby. So we have signed some MOU with some of the industries where we are taking their input in designing the curriculum, which is one thing which actually is needed. So for designing the curriculum, offering the courses, elective courses, or courses that can be offered from the industry people to the students at the institutions. So these things are going on, and many more things would be taken up in future as well. So yes, there is still a gap, but there are efforts being taken by all the stakeholders on that.
No, very well. I think it's great to hear that the way you covered up all the three: government, industry, and academia, how they need to joint up on this effort here. Maybe one of the follow-up question coming to my mind is, as you said, what industry want? As you say, you are doing the collaborations with the industry with some MOU where they need to come forward and showcase or give you much better understanding of what skill set they are looking for, that industry readiness. But do you see that you have also enough professors with that background available overall, and probably, or if not available, then how you need to train the trainers also, right? So is there certain mechanisms which you guys are building from the academia side? Just a short question, not bigger.
Yeah. So there are several initiatives in that domain as well. We have regularly faculty development programs. We have workshops for faculty members as well, and we train our faculty. So right now, what we have done, because we have, as I told you, we have set up a fabrication lab for our students. So for setting up that lab, we had, because IITs are having that sort of lab, but access to undergrads is not very easy in those labs in most of the IITs, as far as I have seen. So what we have done is we have developed this lab which can be utilized to train these undergrad students. So for that, again, what we did is, first we trained our faculty members in IIT. They went there, they went through the complete training process and understood the process. We also discussed with the professors there, and based on their inputs and several other industry inputs, we developed the lab and then started the training process there. So it is being done at a regular pace. And in our institution, we have around, as I said, 20 to 25 people who are specifically working in semiconductors and VLSI. And once a group of people have got training there, they came back and then they trained our rest of the people. So that thing has been done, taken care of, yes.
That's good. It's good to hear and nice to see that how that particular ecosystem is getting built up at the academia level as well. With that, I mean, I'm just coming back probably to Ashok with the thought process of that design innovation, right? So, Ashok, if you could give some more idea in terms of what kind of a differentiation India need to build up, right? Because there are a lot of giants who already have found their niches, and then how in India we can build that differentiated either the design side or also on the manufacturing side. So where the opportunities or where the focus should be from your perspective?
Okay, Yogesh. So see, fundamentally, we have to change the direction of our ecosystem. When it comes to the overall fabulous design ecosystem in India, we have a robust talent ecosystem, but we have a very poor entrepreneurial ecosystem. I mean, I'm sorry, I mean, I have a lot of respect for the MNCs. I'm producer of, some of these MNCs, and I think what they have done for the ecosystem of this country is fantastic, because, I mean, today, I mean, people like me and, you and Hanish, and I'm sure, Shweta also would have had her brush during her research and all with some of these MNCs, right? And they have invested a lot. They have stayed put. Our ecosystem has provided them people, but they have also given a lot of knowledge to this ecosystem. But in this entire journey, somewhere we became habitual to being a mercenary. And the reason I call it mercenary is because we are hired guns. We are a very highly qualified, sophisticated operators, but we work for others. It is not our army, right? And that has to change, right? And I'm not talking only about semiconductors, but entire high-tech ecosystem in this country, right? So I mean, you might have read and you might have heard people saying that, oh, India is a great design ecosystem, but we're a great design talent ecosystem. As I said, entrepreneurial ecosystem is still very, very poor, right? We have all the ingredients in place. I mean, I was just hearing Shweta talking about building the workforce. Now, it has gone into our lingo as well as in our, smaller brain, right? We react that way. Workforce for whom? We don't want to build workforce for, I mean, we should, of course, to all our MNC brethren. But thing is, from developing workforce, we should, graduate into doing fundamental research, doing designs which are going to be prevailing 10 years down the line, right? When India was making all the noises about 4G, some small lab in Japan were demonstrating 6G techniques, right? It's something which we know. I mean, you go probably that lab in Japan and you may find at least one Indian there. So we have the capability, we have all the ingredients in place, right? Now, having worked, I mean, after I came out of Reliance, I've been working with the people, traditional businessmen with very good capital access. And what I realized that these guys have got a fancy for semiconductors, or for that matter, high tech. But they're still very, very, I would say, cautious. They'll ask, if I invest in design, government ka paisa milega kya? Right? Now, that should not be your trigger for investing in a venture, right? Trigger should be the business case, right?
Yeah.
So the whole point is that we have people who can do it. We have access to the infrastructure, soft infrastructure. See, doing a design, high-tech design, and I am not talking about semiconductor. I mean, in your automotive, you can access the simulation tools, wherever you are sitting and, do whatever you want to do, right? Now, we have the access to the infrastructure. We have best of the people in the world. We have really great, academia and progressive people in them. If all of us can work together, and capital can help us. So to me, I think today the number one problem is the access to the capital to the high-tech industry. I was hearing Hanish telling that 15% value addition. I would bet, Hanish, if it is more than 5%. Okay, so that is how it is, and the reason for it is that the big money, they want to see a big building with sophisticated machines, so they want to have access to physical asset and some money thrown in from government. So EMS, all the EMS companies, I mean, so-called Foxcons of the world and their brothers in India, I don't want to take the name of Indian companies, they operate at 6-7% margin. You take out PLI, half of them will close tomorrow, right? So access to capital is a key thing. We have all the ingredients in place. Access to capital is one part, and the change in thought process. It's not engineering the chip, but engineering the thought process is what we need to do.
No, Ashok, I was relating each and every dot, particularly because I'll just give you one example, and I always wonder that in the automotive, there is the BMS, the battery management system, right? This is the core brain of the battery, which constitute 40-50% of your battery electric vehicle cost. Uh, you will not believe that I have seen in that BMS design development industry. You name any big OEM in the world, be it battery manufacturer or the BMS designer linked with that battery or OEMs. There is a three layer. One is hardware, then there's a base software layer and the application software layer. The majority work happens in the base software layer, and you name any company, you'll have hundreds of Indian engineers. So the kind of I would say that 80% of the task of that BMS design is being done by the Indian engineers. You name any global OEM, go anywhere, I'm telling you. Okay, you're saying one, I'll saying the like at least hundreds engineers in any OEM, right? Be it German, Japanese, or even to the extent of the Chinese as well. I would say. And now, but then that it's the other way around, 80-20, I say that. It's 80% of the work which is done by the Indian, but the value is 20%. Whereas the other way around, the other thought processes. So that's where, as you said, that design services is what the people want to do the job, not product engineering or design the product, right? So the value is in the product, final product, not in the services around it. And as you said also, your example on the EMS, I always see that these I have been having so many examples where I see that they have all the in-house team who says, hey, you give me the design problem, I'll make it for you, but I'm more interested in still manufacturing overall. I don't want to own the IP, and I also see that boss is why so, right? You should then get into that product engineering thought process rather than the service side aspect. But I think that's how, as you say, in our genes somehow that workforce, right, is more job security, continuous security without a risk and so on, the value addition part. I totally get it, and thanks for relating that very well. I'll jump on to that aspect with the Santosh further up. Like, what kind of a capital intensive nature this is? Because as Ashok said, there is a lot of capital required here, right? And then when you talk about the overall the ecosystem to make it that supply chain or that infrastructure locally available, how capital intensive it is, and what kind of efforts or what is the situation there? If you could give some more insights on those aspects, and also what need to be done to kind of get that capital or whatever the other dependencies are there, how you can manage those dependencies to make it local overall. So if you could share some of the aspects on that line, it'll be great.
Yeah, sure. That before we move to that, is that we already discussed about labor problems. But in the infrastructure side, we have not faced that much issue. Main reason is that outside countries like Malaysia and Singapore, they are supplying Indian engineers to India. That is the things for the construction industries. So that construction industry like semiconductor fabrication, we are not facing much issues for talent pool because most of the countries there are highly engineers available, so that we can they are like to shift to India. That's the situation happening here. And the capital point of view, as you know that the semiconductor fab, it's huge capital investments required, around 20 to 30 billion investment is for the medium scale of fab. So that the capital point of view, as you know that the semiconductor fab, it's huge capital investment.
Yeah, I think there was some repeat happened, but can you
So that, so may I continue? Okay, so
yes, yeah, it's clear.
yeah, and in that, so 80% of capital investments required for that equipment part. So that 20% will we may utilize for the building the complete infrastructure. So that, as you understand, that total capital goes to the equipment part. So that equipment part, we 100% depending upon the outside countries. So that is happening here. That all the PLS scheme, all the subsidy right now went to outside. So we need to indigenous development for that equipment manufacturing. That is already planning to announce. So we need to develop infrastructure side like capital equipment manufacturing plant in India. Then only that our monies do not goes to outside. That is one important thing. Second things, that out of 20%, the most of the gases, I discussed about the earlier that the gas, 100% gas we need to import from outside India. So that's also major portions. So that the capital point of view, 80 out of 20%, again 5% we're depending upon the other countries. So only that infrastructure part. So the tanks to that EV and the other infrastructure, though we have capable for developing that prefab structures, so that we can able to develop in indigenous. That a lot of companies already available, but the rest of that clean room also, that is the pharmaceutical company is already done a lot of supply chain, that is already available. But in the export from outside, we can hire and we can do it that the clean room, that is not much issue. But so we need to focus on that domestic market and how to develop that this equipment and other gases service in domestic in India. That is very important.
Yeah, so as you said, is local supply chain, and then to avoid the dependencies outside is very critical. One of the aspect on the sustaining the operational efficiency, maybe Hanish, I'll try to understand your view. What kind of a processes, what kind of a technologies are available or which are helping to ensure this operational efficiency for this semiconductor manufacturing? So do you have some example or something which you would like to share in this regards? Anish, or on mute.
Sorry, yeah. So as Marposs, we are offering a lot of process monitoring solutions to monitor the process, to improve the process, to have a stable process, ensuring quality of the component. We have sensors. So we are offering various sensors. One of the example I give you on a back grinding machine. So on a back grinding machine, there's a wafer thinning process. So wafer which already has a chip on it is around 800 micron. So it has to come down to around 150 micron or 200 micron. So there is a thinning required. So we are supplying a sensor which, depending on the material, it is silicon or silicon carbide or germanium arsenide or ceramic or high doped wafers. We are offering non-contact sensors which works on infrared or confocal, depending on the material, where is continuously checking the thickness of the wafer while the grinding is happening. So this way we are ensuring the right thickness is achieved on a back grinding machine and the wafer is thinned from 800 micron to 150 micron. So this is one of the process, one of the monitoring sensor we are offering, but there are others, using acoustics, using vibration, using force, power sensor. So basically we are trying to control and have a stable process while manufacturing.
Okay, so it's good to see that example where you've been able to ensure that the quality aspect overall. Maybe I'll quickly, because we have the questions now coming up from the some of the media, other platform as well, and I'll probably jump with Professor Shweta Srivastava. So the question, I think I'll just read it out. Professor Srivastava, as the head of the Department of Electronics and Communication Engineering, you are at the forefront of educating future semiconductor professionals. What skills and knowledge areas do you believe are the most essential for the student aspiring to join the semiconductor industry in India, and how academia is adapting to meet this kind of industry demand? So I hope, I think this will be probably one of the FAQs you must be getting.
Yeah.
So
So, thank you very much. And it's a very good question. Actually, the student should be aware what kind of skills we need to work on for getting into that domain. So, of course, the basics of electronics, like analog and digital electronics, everybody has to be proficient in when you are willing to work in semiconductors or VLSI domain. And other than that, you have to be good in maybe the tool set, like you have to learn a bit of synopsis, cadence, VLSI designing part, of course, you have to be aware. And then some, because right now, as I said, for fabrication industry, some awareness of the process fabrication is also needed. So that basic requirement is necessary. Other than that, based on your interest, you should choose a project, because learning through project-based learning is something which is actually going to help any student get into a good company. So you need to identify a good project which you want to work on and then start from scratch and complete it. Because in that you'll actually learn every process and every step which is needed to understand the whole thing. And the selection of that project should be based on some industry input, because right now that is what we also want to do. Because in our curriculum also we have many minor and major projects where a student learns from every course. We have a part of project-based learning. Other than that, we have minor and major projects also. So there also the students learn to build a product out of whatever they have learned. And that is very important as far as I understand. Yeah.
great. So I'm sure there'll be more internship opportunities which you see nowadays, because at least I've seen in automotive now we and then I am a firm believer of the internship, because it's a win-win situation. We get a lot of side activities which are kind of exploring nature, which is not a business direct impact, but then which we would want the interns to get opportunity to work, and we get at least some rough format of the output from there as well. So do you see there is a in this regard you get a lot of industry wanting the interns to be part in their summer or in part of probably another one semester or project, as you said, right?
Yeah. So that is what we have, like last 2 years, we have made that change, that because industry only came up to us that they said they want students for complete 1 year or maybe for 6 months. And we had our curriculum revised, because being a deemed university, we have the flexibility to revise the curriculum. So we revised it such that the student can go for one complete year to the industry. So now more than 50% of our final year students are working in the industry right now. So all of them are working one or the other industry, and they are getting that exposure. And when they come back and talk to us, like they are enjoying a lot, because in getting that kind of exposure, industry exposure in their final year or pre-final year, actually. One of the company, they came in the 6th semester when the students were there in the 6th semester, and few of them started crying that, oh, I thought our college life is going to end so soon. We didn't plan accordingly. So the things are actually changing, and the internship thing is, yeah, it's a win-win situation for everyone. Very true.
Yeah. No, I think I really vouch for that, because I think because I've been trying to get those interns even for my current organization, and I always see that 2 months probably are not really 2 or 3 months doesn't give any justice to either us or to the student as well. I think that 6 month to 1 year is really where you kind of have a win-win situation for both the parties, because otherwise it's just that 1, 2, 3 months, 4 months, it's kind of we see that we are investing in the candidate, and by the time you start giving some return on the business thought process wise, we see that okay, it's just gone with the good certificate taken up. So that's where I do see that 6 months to 1 year is really win-win, because they can whatever they are learning, they will be able to really apply in a real world project also. Otherwise, there's no much value addition happens unless you apply that.
That's
That's great. So thank you, Professor Shweta. Uh, we have a question, Mr. Santosh, as the Managing Director of Semicon Fab Technologies. You have first-hand experience with the complexities of semiconductor fabrication in India. What do you consider the biggest opportunities and the competitive advantages for India in semiconductor manufacturing? And what key factors will determine our success in establishing a robust semiconductor ecosystem?
So that is a good question. So that is so India is main focus on that is you already discussed about that Indian market. So that is the main things for that 500 billion market is opportunities there. So any company is setting up that's their business. There is a good opportunity for us. So that is one thing, and its main problem is that setting up that semiconductor fabrication units the time consuming. So it will take another 5 to 6 years to setting up entire semiconductor fabrication unit. I already discussed about the ATMT. We can do that 1 or 2 years, but the fabrication plant setting up, that is very complex process. So that is required 5 to 6 years. That much of time we required to building up the complete ecosystem. That is a challenge. I already discussed that we need to depending upon all the countries. So we need to develop our own ecosystem. Then only we can able to sustain. So anyway, that Indian market is big market. The 140 crore people is there. So that big. Anyway, that a telephone utilization, you can see that is that much of market potential we have. So that is give a better opportunity. Any company setting up that plant is good return. That is we assured that.
Great. So we have a question for Hanish as well. Mr. Arora, as a key account manager at Marposs India, you are closely involved with advanced manufacturing and quality control in the semiconductor industry. What role do you see precision measurement and the quality assurance playing in scaling semiconductor manufacturing in India? And what innovations are on the horizon to support this growth?
So, we all understand that semiconductor manufacturing is a complex process. So there are hundreds of processes required. So at every point, at every completion or the involvement of the process, we need some kind of measurement. So we need some kind of a quality control. That can be inside the machine, or that can be on the metrology part. So the wafers, in cases we cannot touch at times. So non-contact measurement technology, 3D optical profilers, I think will be the key, depending on the process, depending on the measurement. So on a wafer, we may require a step height measurement, or a flatness, or a waviness, or a roughness measurement. There is a measurement required for the wafer on the edge inspection. So if the edge is broken, which may damage the wafer itself. So I think non-contact metrology measurement on a wafer is a key to metrology and inspection as a whole.
Yeah, that's great.
And in our case, we have a group company called Solarius. So we have a tailor-made solutions. So there are solutions, product which are there, catalog selling, but we have tailor-made solutions depending on the customer requirement.
Yeah. So I'm not sure to whom this question I need to address, but anyone of you can try. There's a question from Mr. Ram Patil in LinkedIn have asked, how do Industry 4.0 solutions help the semiconductor industry, and which area are more scope? So Industry 4.0, applying it to the semiconductor industry. Anybody would like to?
I'll answer this question on a sustainability part. So, Industry 4.0, like we work on this. So we have developed a solution called C Energy. So basically it is, so that is on a sustainability and a CO2 emission part. So we are offering power and Hall sensors on the machines and taking the energy consumption data from the machine. We are trying to look at the deviations and try to reduce the energy consumption. So there is a sensor which is part of the Industry 4.0 and work on the sustainability. That is one thing we are proposing.
So I like to add one more thing that so we are also developing that AI-based energy management system. So that will drastically reduce that clean room energy consumption. So looking to the heart of that semiconductor fabrication unit is the clean room. So clean room consume a lot of energy. So that we can reduce by using IoT sensors. We already developed that prototype. So now in the testing stage right now. So that solution will drastically reduce that energy consumption of clean room, and as well as that other like you already discussed about the machinery that we can optimize that based on the process requirement. That's also possible based on AI can provide a better solution in case of energy management. That is the main advantage for us. 4.0 industry 4.0.
This is it. I think these are really good examples ultimately, because at the end of the day, we need to ensure that we need to make that greener or sustainable manufacturing. Just let me check if there are more questions coming up. Okay, so no, I think it looked like we don't have a question, but I have a few things to still further dwell on. It's more on the vision for India's semiconductor ecosystem. So if we look 5 to 10 years ahead, what would you each like to see as a key milestone for India's semiconductor manufacturing ecosystem? So what is a kind of a milestone in which you see for 5 to 10 years where we would be? So maybe starting with Santosh.
So I main interesting point is that so we already start that developing that semiconductor fab. So Tata already started. So I expect that in next 5 to 6 years, Tata will complete that phase one. So we will start with that our own indigenous production from India. That is the one key milestone. Similarly, other companies, major companies will move to the India. I hope that major companies will already provide that their interest. So the next 10 years, we hope that India will develop indigenous semiconductor chips. That is one thing. And I hope that ATMT is a huge role, will provide that building the ecosystem. So India should be the top players for the next 10 years for providing ATMT solutions. I hope that. And India, Tata already declared that they will build that the semiconductor fabrication based on that they will take that energy from the renewable source. So that India will move to the net zero concept. The initial stage itself, so the India can do that semiconductor fab in the net zero. That is a good example we can provide to the world, building the net zero semiconductor fab. So I hope that India can do that. So graduallyIndia will, I hope that India is the hub of that semiconductor. That's all.
Says, I think it's a great vision and we all hope for the same. Hanish?
Yeah. So currently, Indian semiconductor market is valued at around $40 billion, which is projected to increase to $64 billion in 2026 and $110 billion by 2030. The low-hanging fruit we see at the moment, and we see the investments coming, is in the packaging. So first thing is the packaging. Second thing is the ATMP, OSAT. And third thing is the wafer fabrication. I happened to speak to one of the Japanese equipment manufacturer in one of the conference, and he emphasized, and we discussed a lot on this, that in 1980s, when the factories for the Semicon were coming around the world, now probably from 2030 to 2040, that is going to be the decade for India. And what I believe, so already L&T said that the first Make in India chip will be there within next year. But I hope that $110 billion semiconductor market is majorly, covered internally. I mean, not depending as much on the inputs. But the next decade is going to be the decade of India when we speak about semiconductor manufacturing. So that is what we see.
Yeah, so it's next decade, and probably we'll have some vision, as Prime Minister Modi says, for 2047, right? Also, I hope by that time we should be totally self-sustainable with a more global footprint for export as well. Yes, maybe Professor Shweta, your insight or your vision.
I agree with what Santosh and Hanish had said, but just to add on to it, I would like to see more of our research coming into like product formation. So, like India, a lot of research is going on, but most of our researchers are focusing towards just publishing a paper or something like that. We need to focus to do research which is actually converted into a product. So that is something which should come up and will hopefully in next 5 to 10 years, we'll have more of our research converted to products.
Great. So maybe the last question, probably around quickly here is, what is a future market trend which you come across in your own areas, rather than in general? Obviously, you can give general thought process, but then any other thoughts which you have, I would probably like to understand from the future trend perspective, and it could be beyond the manufacturing as well. So maybe Santosh to start with.
So you mean that the India will the next 10 years, the similar like the question, right?
Yeah, maybe on the technology side, I'm trying to know the beyond the vision, what kind of a future technology trend or even the manufacturing trend related thing, right? Which is where what's coming in India or globally, I would say, not necessarily now the India angle. You as one of the where your observation. I mean, I can give you one of the thought process from my the experience here is in the semiconductor, like earlier CPUs, GPUs. Now there is a more FPGAs and the ASIC are getting. And in the ASIC, the where I was part of the Cynthian, which is a ultra low power ASIC application. So it's a purely neural network where any other chip would probably last the battery will last for 3-4 days using processing one of the AI or neural network model on normal processor, whereas on this processor, the battery will last for a year. So you can see the kind of a processing efficiency of 100 to 200 time multifold, right? 100 to 200 times less power required. So that's how the trend, which I see from the cheap perspectives, right? So that's one of the example, and then maybe I would like to get your kind of a thought process in any, even in the infrastructure, what kind of a the trends which you see, or same thing from Hanish and kind of a technologies wise, what kind of a future trend which you are seeing, which will help India or which is happening globally as well?
So I think 2 points I noticed, that is the EV market in India. So EV market is growing. So that next 10 years, I hope that India already make a vision that the complete we need to focus on that EV and the diesel engine need to remove from the market. So I hope that next 10 years or 15 years, the complete vehicle will in the EV market. EV, that is one option is the. So that is a vision for India. And second, the renewable source of energy. India, as that is solar, is now catering that complete energy sources. So we need to produce our own solar chip in India. So completely. So only the some portions only developing in India. So we need to develop complete solar chip in India and catering the gigawatt requirements the next 10 years. These two are the key market. I like to discuss about this future market for India and as well as world.
That's very much apt, I would say, because one of the thing I would, being coming from automotive now we say that the car is becoming the mobile running on four wheels, essentially. And then when you say the mobile, as Hanish was mentioning, there's so many microchips, right? And now everybody is talking about a trend in the automotive is beyond the EV is software defined vehicles. So where ultimately you will see the huge exponential growth in the computing power. So there's a SDV is based on there's a one high or hyper computing power, if I have to say. is going to be there, and that's where then the number of that chips with the lot of controllers is going to change, and then that's where the automotive is really focusing. How do we capture that semiconductor dependencies locally overall, and then that demand is going to be huge. And now what is happening is also that a lot of be it the Indian companies likes of Mahindra or Tata, or the Japanese companies or the European companies, they're not just now catering to the Indian market, manufacturing in India. They're trying to capture the lot of export market from India. So they're becoming, and for that also again, you need to have a lot of domestic demand for those exports market as well in the automotive overall. So yeah, I think thanks Santosh for touching on those points. Hanish.
So I would emphasize on three things. So first is the digitization. So the government pushes there for a 1 trillion digital economy. So if we have to come from 3.7 billion GDP today, economy today, to 7 billion by 2030, so there is 1 trillion has to come from the digitization. Second is I can't agree more with Santosh ji on the renewable part. So the wind and the solar sustainability and those, so that is the second thing. And the third thing is also mentioned in the budget and normally is a focus, which we are speaking, is a sunrise sector again for the semiconductor and electronics manufacturing. So digitization, renewable energy, and semiconductor and electronics manufacturing ecosystem. I think these three is the key.
Yeah, I think, and I like the second, and particularly the second and third aspect, where now the geopolitics will play a more crucial role to
Exactly.
to have that energy dependencies or even the semiconductor as strategic dependency to ensure that we have the focus on that there. Professor Shweta?
I think mostly the points have been covered. So it's, yeah, EV is coming, and renewable and solar energy along with the semiconductor technologies. And we are ready with what kind of human resources needed for that. So that is what I can comment on. Yes.
That was great. I think one of the thing is which I like nowadays with the academia is there's a quite openness, and there's a quite industry also trying to get engaged with the academia in terms of even the lot of events are happening along with the industry at the institute level, which you never had seen any, but there was used to be just sometime guest lectures happening. That was a maximum kind of a level of engagement. Now where there is faculty and industry, they try to engage on a workshop, a long duration workshop, the projects, the internships, and I think, and the labs, right? And there are a lot of institutes where they have given a center of excellence kind of a labs for those industries within the institute, which is again, I think it's a win-win situation for both the and then the like Atal or other incubation centers which are getting established. So it's really great ecosystem which I think academia is placing on. So I'm happy to see it. As you said, there is a good fab lab is kind of getting running there as well, which really adds a good value for students to make it to industry readiness. So I think overall, I'm really happy the way we have the really great contributions, good insights, interesting facts, figures, right from the policy, the business models, to the infrastructural, to the local dependencies, to the processes and the quality control aspects that need to be taken care or ensured to deliver the global world-class products. And obviously, we got to know how the academia is gearing up to ensure that the industry-ready talent is available to deliver those kind of both manufacturing as well as the design side needs. So with this, I really would like to say a big thank you and round of applause, I would say myself on this platform here to all of our panelists. And I wish you a great time, and I wish, as you guys saying, by 2030 or 2047, we become one of the major or one of the largest manufacturer, as well as a innovation guy. I would say I'm a more in design engineering guy, so I would probably hope that we become a more product engineering guy rather than the design services guys in the industry, and add a great value, as Ashok was mentioning. So with this, thank you everyone for your great contribution. Thank you, Dinesh, for having me and this opportunity where I could really get a good insights and learn from the speakers here. And thank you for all the audience who have joined from different platforms. I am sure you would have got it really great insights to take forward in your industry to apply or learn further. So thank you, Dinesh, and thank you, everyone, and have a nice day.
Thank you.
Thank you.
Thank you. Thank you.